This is Statistics Lesson 2. So in the first lesson we talked about measures of central tendency, or the search for finding what's average or what's normal in a set of data. So those were three tools that we could use to figure out what's normal. Another tool that we're going to talk about today is called weighted mean. So weighted mean is a lot like regular mean, regular average, adding up all the numbers, adding up all your data, and dividing by the number of data points that you have, except it gives extra weight to certain data points. So you've experienced this in school all the time. So your final report card mark is not usually just all your marks added up and then averaged out. It's a little bit more complicated than that because certain things in your course are worth more than other things. You spent more time on some things. Some units were longer than others. And so then those things are given more weight in the average than the things that you did for one day and then you were done, right? Another example would be any judged sport. So let's go with figure skating. So in figure skating, you're given marks for certain elements in your program. Like if you do a triple axel, it's worth a certain number of points. And then if you do it really well, you get more points for it. But if it's done in the short program, so you do two routines in figure skating. You do a short program and you do a long program, or the free skate. And the free skate is weighted more heavily than the short program because it takes more stamina, it takes more effort to do really well in the free skate in the long program than the short program. And so your final score is weighted more heavily on the long program. Now you may ask, how does he know so much about figure skating? Never you mind. So let's look at a situation where there's a difference between mean and weighted mean to see what the difference is. Eunice has the following marks in her geography class. What is her average mean mark in geo? Okay, so here's a table with all of her marks. She got 90%. Her mark was 90 on her homework. Then she had 62 on her quizzes overall. So these are all averages of all of these things. Projects, she got 68. Exams, she got 75. And oral presentations, she got 85. So she was really good at the homework. Quizzes maybe weren't her strong suit. But we're just going to give her an overall average mark for this course. So we're going to just add up all of her marks. She got 90 and 62. And then we're going to divide that by the number of marks that she had. So there's 5 of those. So in order to get the mean, you add up the data and divide by the number of data points. And there's 5 data points. And when you calculate that mean, you get 380 on the top, divided by 5 on the bottom, which is 76%. Okay, so her average in the class would be 76% if you just considered all of those different things worth the same amount. So her homework was worth the same as her exams. Now let's look at it if we would weight these things. A lot of the time, different kinds of assignments show your learning more strongly or more powerfully than others, and so they should be given different weight. And so if you look at the weightings here, we have a weighting of 10 for homework, 20 for quizzes, so quizzes then are worth twice as much as the homework is. Projects are 15, so they're right in the middle. Exams are worth 50, so they're by far worth the most. And oral presentations 5. Maybe there only was one oral presentation during the year, and so maybe it should be worth the least out of all of those things. And so the weighting is all of these things. So in order to weight each of her marks, all we're going to do is multiply them. So she got 90% on 10 items. Let's say the weight is 10. So we go 90 times 10, and that would give you the weighted mark. And so her weighted mark is 900. Okay, 10 times 90, 900. So we're just going to do that for each of these things. We're going to just multiply each of those. So 20 times 62 is 1,240. And then I'll fill in the rest of these. So those are all her weighted marks. And so you can see pretty quickly that out of all of these things, exams, she gets the most points for her exams. Okay, so now in order to figure out what her weighted mean is, we're going to add up all the weighted marks and divide by the total weight. Just like with regular mean, you add up all of the data points, or you add up all of the marks, and you divide by how many marks there are. With weighted mean, you add up all the weighted marks, which is just what we figured out, and you divide it by the total weight. Okay, so the total weight, if you add all these things up, is 100, which makes sense. If this is a teacher's grade book or something, then you would get 100% is the total weighting. And then all of her weighted marks, when you add them all up, you get 7,335. Okay, and so we are now going to just take the 7,335, divide it by 100, and that's going to be her weighted average, or her weighted mean. And so we're going 7,335 divided by 100, which gives you 73.35%. Okay, so if you look above, her non-weighted mean was 76%, so her final grade, just counting all the things to be the same value, was 76%, but if you weight all of them, then her final grade is a little bit lower, 73.35, because the things that she did really well on weren't weighted as heavily. She did really well on homework and oral presentations, but those didn't have as much value as exams and quizzes. And so her mark went down a little bit because those heavier things were lower marks. Now here's another example. Jennifer works in the HR or human resources department of a large company. Usually those people are responsible for hiring people and taking care of complaints and things like that. She assesses job applications in this case. Avery and Bryn interviewed for a position. Their scores from 1 to 5 are in the chart, with 5 being the highest score. Who should get the job? So, education, experience, communication, and leadership are the 4 categories. So Avery had 4, 5, 2, 2. So she was really good with education and experience, but maybe her communication and leadership weren't awesome. And then Bryn was 3, 2, 4, 3. So she had nothing that was as outstanding as Avery had, but she did much better on communication and leadership. So if we were just going to figure out what the mean is here, then we would add up 4 plus 5 plus 2 plus 2, which is 13. And then 13 divided by 4 will give you the mean for Avery. 13 divided by 4. And that's 3.25. So Avery's total score, or her mean score, her average of those 4 categories, would be 3.25. If you do the same thing for Bryn, she adds up to 12. And so her mean score would be 3. So just judging by those things, then Avery should get this job, right? But maybe those 4 categories are not worth the same amount. Maybe they want somebody who has leadership skills more than they want somebody who has experience. Who knows? So let's see what the weightings look like for this job. So education has a weighting of 10, experience 5, communication 20, and leadership 15. So it turns out that experience really wasn't all that important for this particular job. Apparently the training program is great. Okay, and so they were really looking for somebody who was a good communicator and who had good leadership skills. Now you can probably guess whose score is going to be changed the most here, because we just pointed out that Bryn had better communication and leadership scores than Avery did, so Bryn is going to benefit from this weighting. But let's weight them, figure out the weighted mean, and see where that takes us. So remember, we're going to multiply those two things. 10 times 4 is 40. 5 times 5 is 25. Now I'm going to fill out all the rest of these things and we'll take a look. So here are their total scores, their total weighted scores. So Avery's got a better education score overall. She's got a much better experience score, but again, experience wasn't worth nearly as much. Her communication score, though, is way worse than Bryn's now, because it was more important. And leadership, Bryn had a much better score as well. So when we add all these three things, there's 4 of them. When we add all of them up, we get 165 for Bryn, and we get 135 for Avery. So you can already tell who's going to have the better score now. Bryn has a higher weighted score, but now we're going to just divide it by the total weight, and the total weight of all of these things isn't 100 in this case, it's just 50. But that shouldn't really matter, because we're just going to divide by whatever that weight is, whether it's 6 or 100 or 7,000. It doesn't really matter. We're going to take the weighted score and divide it by the weight. So 135 divided by 50 is Avery's score, and Bryn's score is 165 divided by 50. And so when you do those divisions, you get 2.7 for Avery's score, and you get 3.3 for Bryn's score. So compared to the regular mean, Avery's score has gone down because she didn't do as well in the important things, and Bryn's score has gone up because she did better in the important things. And so weighted mean differs from the mean because certain data points or certain categories are more important and they're given more weight than others, whereas normal mean just takes everything the same, you add them all up and divide by the total. So weighted mean is going to make a difference in those cases.